Now today we're going to do Euclidean geometry, and we are given that ABCD is a cyclic quadrilateral with AC being equal to AD. Then we have the tangents AT and CT. Then FBC, ABE, AHC, and DBT are straight lines. Prove that B1 is equals to B2. So we must prove that B1 is equals to B2. Okay, so from that, I think if you put your if you look at this B1, it is equal to this angle, which is the interior angle of a cyclic quad. So you can say that B1 equals to angle D, exterior angle of cyclic quad. Okay, and then you can say that this angle is equal to this angle, so making it equal to this angle also. So angle D equals B1 equals C3. Reason being is angles opposite equal sides. Remember, we were given that these two sides are equal, and thereafter we must now show that B2 is at least equal to either D or C3. So if you put your hands on A and D, put your two fingers there and go to C, and come from this side also and go to C, and then take your hands back to A and D and move to B, you would see that they are forming angles in the same segment. So C3 is equals to B2, but now C3 is also equals to B1, remember? And then we can say angles in same segment. Therefore, B1 is equals to B2. Okay, now we must prove that BECH is a cyclic quad. So we must imagine a circle around here. Okay, and then if we imagine a circle, so this angle, the whole angle C, let me use another color. This whole angle C here, C1 and C2, is equal to D1 and D2 due to the tan chord theorem. So angle D is equal to C1 plus C2 tan chord theorem. But then remember that we had proven that B1 is equals to angle D. So proven in 10.2.1. So from here, remember? So now, if this is a cyclic quad, then the exterior angle of a cyclic quad is equal to the interior. So we would say that, therefore, it is a cyclic quad. Then our reason would be converse exterior angle. Okay, it is sorry, not B1, B2. B2. Remember we said B2. So this angle out, this angle here is equal to this angle. Okay, so now prove that CA is a tangent to the circle passing through the point A, B, and T. Okay, so firstly, we could start off by saying that angle B2, so angle B2 would be equal to this angle and this angle. Since it's a triangle, we can say that B2 is equals to A3 plus T1 exterior angle of triangle. Okay, and then we had in the last question that B2 is equals to C1 plus C2. Remember we proved this. And then AT is equals to AC, tangents from the same point. Okay, then now C1 plus C2 is equals to A2. So let me write this down. C1 plus C2 is equals to A2 plus A3. And the reason for that is angles opposite equal sides. So this C1 is equals to this A2 plus A3. But now also A2 plus A3 is equals to A3 plus T1. And the reason for that is angles between line and chord, or you can say converse tan chord. Therefore, you could say that A2 is equals to T1. This would be a reason. Then you can conclude that CA is a tangent.